Now that we've walked through the source code of the ThreadJoinTest case study, it's time to take a step back and evaluate it. In this part of the lesson, therefore, we'll discuss the pros and cons of using various Java functional programming features in this case study. The cons that we discuss will motivate the need for more advanced Java concurrency and parallelism frameworks. We'll cover these frameworks in later courses. For the time being, please take a look at the link at the bottom of the slide for a wealth of material on these fascinating topics. We'll start off by discussing the pros of the ThreadJoinTest program. The foundational Java functional programming features, such as lambda expressions, method references, and functional interfaces, improve the ThreadJoinTest case study vis-a-vis an earlier Java object-oriented version that you can find in the link at the bottom of the slide. The earlier Java object-oriented implementation required more syntax and also used traditional for loops. Unfortunately, traditional index-based for loops often suffer from off-by-one errors. Likewise, the use of object-oriented features, such as anonymous inner classes, can be tedious to write due to the fact that there's extraneous syntax required relative to more concise modern Java features like lambda expressions and method references. The object-oriented version of the ThreadJoinTest program was thus more tedious and error-prone to program as well as to maintain over time. In contrast, the Java functional programming implementation of the ThreadJoinTest program that we've been analyzing is more concise, extensible, and robust. These improvements come from its application of modern Java features like for-each methods, functional interfaces, method references, and lambda expressions. In particular, the use of for-each methods avoids those nasty off-by-one fence post errors that so commonly occur when using index-based Java for loops. Likewise, the use of functional interfaces, method references, and lambda expressions simplify behavior parameterization. For example, by parameterizing the makeThreads factory method with a function, we can then flexibly provide it with different task implementations to bind with the threads it creates. Now that we've evaluated the pros of the ThreadJoinTest program, let's discuss some of its cons. It's important to recognize that there are limitations with foundational Java functional programming features. In other words, these features aren't all rainbows and unicorns. In particular, accidental complexity still lurks in the Java functional programming version of the ThreadJoinTest program. Accidental complexities arise from limitations with software, techniques, tools, and methods, as described in the classic paper No Silver Bullet by Fred Brooks. One of the accidental complexities associated with the functional version of the ThreadJoinTest program is the need to manually create, start, and join thread objects. A common novice mistake, which sadly I still do from time to time when I program at this lower level, is to forget to start threads, which means that no computations will occur. Another accidental complexity can occur when we try to join with the threads using the Java for-each method. Note the verbosity of handling checked exceptions in modern Java programs. A helper class can provide methods, such as the rethrow consumer adapter function shown here wrapping ThreadJoin, that enable less verbose use of checked exceptions in Java functional programs. Although there is some controversy about this type of exception laundering, please see the link at the bottom of the slide for more discussion of this approach and its pros and cons. Yet another accidental complexity in the functional ThreadJoinTest program is the fact that only one concurrency model is supported. In particular, the thread per work of Shakespeare model hard codes the number of threads to the number of input strings. Unfortunately, these accidental complexities are hard to fix, since the code is not easily extensible without major changes. In a nutshell, the ThreadJoinTest program's implementation is insufficiently declarative, even though it's certainly an improvement relative to the earlier Java object-oriented version. A related issue is that the structure of the concurrent implementation of the ThreadJoinTest program looks much different than a sequential implementation that provides the same functionality. We'll now briefly explore how to address the cons of the ThreadJoinTest program. Solving the accidental complexities we just discussed require more than just the foundational Java functional programming features. Fortunately, modern Java provides other frameworks, such as the sequential and parallel streams frameworks, that can be applied to address these accidental complexities more effectively than by using the foundational Java functional programming features in isolation. Java streams are a high-level declarative framework provided in Java 8 and beyond that support functional style operations on sequences of elements, such as map-reduce transformations, filtering, slicing, searching, matching, and much more. It's beyond the scope of this course to cover these topics in detail. However, we'll discuss them in future courses, and you can also get a preview of this material by taking a look at the videos in the link at the bottom of the slide. In addition to watching the material from my other courses on Java streams and parallel streams, you might also want to take a look at this implementation of the barred stream test case study, which provides a Java streams and parallel streams version of the ThreadJoinTest case study we've been walking through. If you examine this code, pay careful attention to the fact that the structure of the sequential implementation is nearly identical to the structure of the concurrent implementation. In particular, the only real difference is that the sequential version uses the .stream factor method to create a sequential stream, whereas the parallel version uses the .parallel stream factor method to create a parallel stream. So that's the end of our evaluation of the pros and cons of the ThreadJoinTest case study. Hopefully you have a better understanding of how Java functional programming features represent an improvement over the more traditional object-oriented features, as well as a renewed interest in learning more about Java's advanced functional programming features, such as streams and parallel streams.